This is Mr. Caslin. We're going to talk more about this exponential decay. I think in the second problem that you had, let's find it. Okay, I was looking at this next problem down here. Now this, we're going to use the same formula, but we have different information that they're given. All right, so now we're looking at the decay of this carbon-14. They tell us the half-life, they tell us the initial quantity, and we're trying to find the amount after 1,000 years. So it's opposite of the other problem. The other problem, we knew the amount after 1,000 years, and we had to find the initial quantity. All right, so same formula. Notice they didn't tell us what B is again. So the first thing we're going to do with these problems is figure out what our constant is. All right, carbon-14 has a different constant of decay. So let's use our half-life. Remember, our half-life means we have half the amount of material when we're done. So half of what we started with. So if we started with 1, we've got a half when we're done. All right, so always use 1/2 and 1 when you're trying to find, when they give you the half-life. E is our base. We don't know what B is. And we're told the half-life in this problem is 5,713 years. Okay, remember when you multiply by 1, this part's not really necessary. So use what you know about logarithms and exponentials to solve for B. Okay, again, you're going to solve this, you're going to get B. B in most cases is a very, very small number. All right. Even though you're rounding the final answer, I would keep 4 significant digits. That means you've got 3 zeros here, so I would document this number to 4 more places and use those numbers throughout your problem. Okay, so you're solving for B. B could be a really small number. Remember, your calculator might give you scientific notation, so convert your scientific notation to decimal. Okay, so that's what we're going to use your half-life to find out what B is. All right, so once you know what your B is, now we're going to go back, and step 2 is solve this equation. All right, so what do they tell us in this problem? We're trying to find the amount when we're done, so they give us an initial amount, I believe, which is 55 grams. Base E. B is going to be the number you calculated for B, and it wants to know how much material is left after 1,000 years. So your time is 1,000, and you're doing this calculation. You're trying to find out after 1,000 years how much of the material is left when we started with 55 grams. So now you're just solving this. These x's aren't variables. This is just whatever number. When you do your B calculation, just you're filling in your number here. Okay, so you have everything you need to know here. You're just finding the value for this. Let's try this again, the value for this. Okay, so again, same process. Take your half-life, solve for B, and then plug in all the information you know, including B, and figure out what variable you're missing, either the initial amount or the final amount. You may have a problem where they give you initial amount and final amount. Well, this is the initial, the final, and they want you to solve for how long did it take to decay to that final amount. So you'd solve for T. All right, so you got to figure out what B is first. Once you plug in B, you should only have one variable left. Solve for that variable. All right, after you do it and when you're on your online site and you're not getting the right answer, if you need some more help, let me know. We'll talk to you later.